So for the last decade, I've been primarily looking at sensor technology and how do we use the information we get from it to make better decisions in turf. And when you're trying to predict something, trying to take information and predict a value or predict what's going to happen in turf, you have to have something that's on the same playing field at all times. If you have to calibrate it, technically you should be calibrating it every time you stick it in the ground. And that's always been the problem with some other technologies. You have to understand this, because if you're trying to say 20% moisture today is the same 20% you see next week or next year, you have to be very sure that that is the same condition that exists. If it isn't, then you have to recalibrate and recalculate your predictions. We've honed in on this technology, utilized that very unique sensor that requires no calibration, and developed something that has been influenced by greenkeepers and superintendents around the world, and we continue to develop this to make these kind of decisions. Is turf management in the UK different than everywhere else? Some will argue it's a lot different. We don't want to be Americanized. We don't want to manage like the Americans. The bottom line is turfgrass is turfgrass, plain and simple. And if you don't manage air and water exchange, your turfgrass will suffer, plain and simple. If you want the best putting speeds, the smoothest surfaces, the most satisfied players, these variables are very consistent no matter where that grass is grown, no matter what soil type it's on, anywhere in the world. So in turfgrass management, we have some very fundamental processes, and you guys and women have probably heard these terms before. Like, why are we talking about photosynthesis? I learned about this in Turf 101. We all know that photosynthesis requires sunlight. But another thing you might not realize is photosynthesis is also temperature dependent. And the one thing that affects the temperature of the canopy more than anything is too much water and not enough air. We don't have to have a very hot day, but if we have too much water in the profile and we get a very sunny day, the canopy of that temperature can heat up into the mid-30s and higher. It's a stress that plants sense, and they shut that process down. That's a problem. So bottom line is, if you manage your air and water exchange in that profile, we can actually reduce the temperature of the canopy. And now you have technology that can measure this. Why is that important? The other thing that affects this process is the availability of CO2. We hear all this argument in the industry about there's plenty of CO2 in the air. Photosynthesis doesn't take CO2 that's measured by a weather station at the top of a volcano. It takes the CO2 coming out of the ground. That's where most of the CO2 used by turfgrass starts and where it comes from. So what happens is we build up a lot of organic matter, we get a layer, and guess what gets shut down? This. So now we don't get air in or air out. Now we have a real problem, because not only is photosynthesis failing, but also respiration, which requires free oxygen flowing through the soil, that also gets shut down. If these two processes stop, your grass has no chance of getting you the performance that you're after. Zero. When you see black layer, that's the result of this shutting down weeks or months before you saw that black layer. It didn't just happen overnight. It doesn't form from sulfur fertilizers. Don't let anybody tell you it does. Sulfur will never form black layer. What forms black layer is the lack of oxygen, plain and simple. When you're in anaerobic conditions, those microbes still need oxygen, and they steal it from sulfate ions, iron sulfate, magnesium sulfate, manganese sulfate. They'll take an oxygen from that SO4 and leave behind a sulfide precipitate, which happens to be black. Clogs the pores, further blocks the air, and the problem just gets worse and worse and worse until what? Until we remove that black layer and add air. Black layer goes away. So if you control your anaerobic conditions, you'll prevent black layer. Anaerobic conditions are caused by having too much water and not enough air. The other two processes are transpiration and translocation. The last one, translocation, is the movement of things within the plant or from outside of the plant into the plant, and they move around. And we know it happens best when the other three processes, photosynthesis, respiration, and transpiration, are optimal. Transpiration is the movement of water from the bottom to the top of a plant. It only moves in one direction, never goes downward, and it acts like the skeleton of the turf. It holds it up, it gives it rigidity, gives it recuperative capacity from stresses. It gives you less friction on ball roll. So if transpiration is nice and rigid and firm and the plan is performing, we have a better ball roll. If we get into a pocket green or we get into a humid condition where the grass starts laying over because transpiration is shutting down, we have poor ball roll because we have more friction on the ball, more kind of laid over leaf blades instead of that nice upright dense turf. So this is how all of these things affect turf performance. So when does transpiration slow down or stop? Well, this depends on moisture down here being higher than up here. As we build up organic matter in this region and we start to hold more water, now we have too much water here compared to what's down here, and what happens? Transpiration stops. It just stops until that gradient changes again. It's just a physical response in turf. I took cup cuts from all over the world and sliced them down in 3-centimeter slices. There's down to about 7 or 8 inches deep. Whether it was a clay or a USGA green or a modified native push-up, more than 80% of the water and salts resided in the top 5.5 centimeters. Didn't matter how deep the roots were, didn't matter what the soil type was. That's where a lot of organic acids are built, and that's where a lot of them come out of the plant. It's like glue, it's like super glue. It holds on to moisture, it holds on to salts. And we start to see our roots die back. We see our perk rates at 12 to 18 inches an hour at growing turn into 3 to 6 inches an hour within 1 year, and less than that in year 2. All because of this organic matter buildup. So bottom line is, if you want to sense where a problem might be developing in your turf, it will always start up here, plain and simple. If I stick a center tine in that measures from here to here, all I'm doing is diluting that measurement across a deeper depth. So say I have a problem developing here, and let's just say that's holding 40% moisture, and down here is holding 9% moisture because it's straight sand, and I put a center tine in that measures through both of those, you're going to get an average of about 19% moisture. It's going to say, oh, you're holding about 19 or 20% moisture in your profile. But if you put a sensor in that just measures this area where the problem's developing, it's going to say you have 40% moisture, you have a real problem. Start measuring there, everything else falls into place, plain and simple. You don't want to use a shallow depth in the summer and a deeper depth in the fall because you change your reference point. You always want to measure against a consistent reference. So all the cultural practices that we employ are designed to improve this air and water exchange. How are we doing this with technology? Well, you can go out and measure salts, you can go out and measure moisture, you can go out and measure temperature and light and all these different variables with a bunch of equipment, and then you've got to calibrate them all together and put it together. Nobody wants to do that. What we've attempted to do is take that sensor that the USDA uses, stick it on a portable device, add GPS so you have precise measurements of where you're taking readings, and collect the most influential variables at the same time. This sensor never requires you to calibrate it, so you don't have to worry about changing soil conditions, compaction, whether you fertilized or not. It will always give you the same reference point. And that's what this tool is. This is called the Pogo. It measures moisture, temperature in the canopy, and salinity as decisiemens per meter. Also now measures salinity concentration. It'll tell you how many salts are present for the amount of water you have, which is important, more important than just EC alone. This sensor is meant to target that region that we just talked about, that top region where the problems will develop first in every turf system. How do you measure? Well, there is some science behind how many readings you should take. What we do know is when you take about 2 readings for every 90 square meters, that will give you a pretty good reference of that putting green. A lot of people think they can go out and stick one sensor in the ground and say, oh, this is my reference point, I know I'm good on the course. You can't do that. Because if you measure across a green, you will see tremendous variability from spot to spot. Where you walk on the green, where you walk off the green, whether it gets more sunlight or less, whether your sprayer overlapped this morning when you put out a foliar application. All of these things cause a lot of variability in turf. If you want to measure what that green is seeing over time, you have to have representative data from across that green. You get volumetric water content, salinity or EC and decisiemens per meter, and some of you might say, I don't have a salt problem, it rains like heck here. Yeah, but you're fertilizing, and if you're fertilizing, you are managing salts. That's what fertilizers are. EC measures all salts in solution. whether it's a nitrate, phosphate, calcium, magnesium, sodium, chloride, anything with a plus or minus next to it affects EC. So you can gauge your fertilization practice by measuring EC. Temperature Celsius in the canopy and temperature Fahrenheit, which we don't worry about too much here. Number of samples you've taken for that particular zone. It has a GPS button indicating the GPS satellite strength. You can take a memo or a photo with that device. And if all you want to do is get information on the spot, this is all you need. But what we've realized about this industry is we want to analyze this over time visually. So we've invented a cloud system that syncs with the technology on the ground. You can take a reading, upload to the cloud, and have reports sent right back to your device while you're standing on the green now. So how does this work? This is out in the field. Superintendent says every summer I lose grass on these greens. So we go out and take some readings, and sure enough, these spots where he says he loses grass, this is early June, by the way, 48.8% in these areas, and that's where his black layer is starting to form. The average of the whole green was 36%. So then we put it on a visual analysis. This is the kind of stuff that comes back to your phone, and you can see the variability of moisture throughout that green. And sure enough, everywhere where these dark blue spots are, the superintendent said, I lose grass there every year. Mainly in the middle, because that's where they always put the cup. I mean, literally in the same spot. By the way, this measures where you're putting the pin every day since it has GPS. So you can actually measure your pin patterns, send the pin sheet to the pro shop if you want. These are just extra things that you can add to the system. Also, moss was showing up. It wasn't rocket science. So what do you do about it? Well, you use this tool now to gauge your cultural practices. Drive that number down, because if you don't, come summertime, this is going to be a big problem. A lot of people think the wetter it is, the slower the ball roll. Or the drier it is, the faster the ball roll. Absolutely false. Because what happens to grass when it gets too dry? It has thatch, unlike any other plant system. Thatch gets spongy and brittle when it gets too dry. And when it gets spongy and brittle, it actually puffs up a little bit, adds more friction to the ball, and ball speed goes down, gets worse. So every green has an optimal moisture for an optimal ball speed. Once you find that moisture, then you can drive your greens to that level day in and day out. You set those colors are all driven by your thresholds, the warnings you set. And you learn these within about 30 days or 60 days of using this technology. You'll know where your optimal positions are. Or you can send in what's called a Pogo Lab Analysis. We'll look at all your nutrient makeup. But one of the most important things we identify is how much water can your green hold? What's the maximum water can that green hold? And we look at the whole core, not just the soil. So this test will give you those critical readings. And again, it's critical low, low, high, and critical high. If you're driving right down the middle of these numbers, that's ideal. So you can do it by eye over time. You can do it with science and identify those numbers. So then what do we do with all this information? If you want to analyze this over time, the simplest way to do it is through a cloud-based system, and I'll show you why. With this, you can measure a zone, 1 green, 2 green, whatever. It takes about 2 hours to set up a golf course. Once the course is set up, all you have to do is take samples. This does the rest. You upload data, and you get all of this information, all of these different features. At a quick glimpse, you'll see everywhere you've taken readings on your property under these little bubbles indicating if I have a problem. In this case, we're looking at dark blue showing that I'm wetter than I want to be. This red one's indicating I'm very dry. You can also switch this over to salinity or salinity concentration and look at those at a glance. Or you can dive in and look much more closely. So now the question comes, I was in your shoes. I don't have time to sit at my computer. I had 8 people on my staff, a 200-acre property. You're catering to your members every day. I can't go sit at the computer and do all this analysis. So now these reports come to you. You upload data. This is actually off of an Android phone, and the analysis of the data you just took comes right back to your phone. You can scroll through every green. You can look at the water patterns, what the numbers actually were. You can scroll down to salts. You can look at salinity index. You can look at temperature stresses, all in real time. You can do trend analysis. This green bar is driven by those optimum levels that you set, and it will tell you where you are in relation to those levels at any given time. If you took any pictures with that app, those pictures show up right on the chart. These little black icons. You can click them and it'll show you what it looked like. You can take a note saying something about the weather, whatever it might be. You can now do this stuff. All you have to do is take 9 or 10 samples off of a putting green. This does the rest. And if you want to print this stuff off and give it to your superiors and show them what's going on, piece of cake. This is what superintendents have asked for, and makes it a lot easier to use technology today than you could have even just a year ago. What are some other things you can do? You can assess where the cup is, where it's been placed. In this case, here's a moisture stress versus a salt stress. You can look at the history of the cup. So if you're not sure if your team's putting the cup, spreading it around, now you have a way to measure that. And measure it on top of what's going on below the surface. Since it's a full-scale irrigation mapping and landmark mapping tool now, you can actually do your own as-built on the property. So for instance, take this hole here. I want to measure where the sprinklers are. I want to measure where the valves are. I can log those. I want to show where my water line goes, where all my irrigation lines go. The wires, the pump house, a controller, drain lines, catch basins. Anything you can do with GPS, you can do with the Pogo system. You can make your own as-built of your property over time. If you know where the herringbone pattern is in your greens, you can actually step that off and measure that. And you can turn these layers on one at a time. And all of this still is on top of the agronomy below it, which you can turn on and off at the touch of a button. And all of this is printable. So you can actually print out a laminated sheet of your property, use it for setup and for maintenance purposes and that sort of thing. Here's, if you just want to look at the agronomy, here's moisture variability. Here's the same green with EC variability. Now, a lot of people say, what's the difference between salinity and salinity concentration? So if I have a glass of water and I put a teaspoon of salt in it, that has one level of salinity concentration. If I have the same amount of water in another glass and I put twice as much salt, my concentration is twice as potent. Turfgrass senses that concentration. So if I fertilize my greens and my EC concentration climbs high, this is when you see succulent growth or a flush of growth, or if you go over the top, you see yellowing. We call it a burn. We don't really burn turf. What we're doing is salts will always go from a high concentration to a low concentration. There's water and salts in the plant, and then you put out a bunch of salt outside the plant. That salt sucks the water out of the turf and moves into the plant. So as the turf becomes drier, it also becomes saltier, and that's what causes that yellowing. We're literally pulling the water out of the plant. We don't burn it. It's just an effect of salt in the presence of a leaf tissue. So concentration is important. So if you want to analyze the difference, there's EC, there's the same green, that's salinity concentration, and you can see the stress is much less. That means I have just the right amount of water to manage the salts that I have. So I would operate off of salinity concentration before I operate off of EC alone. That tells me really what my variability is. Another thing you can do is if you want to measure distribution uniformity, if you want to do an irrigation audit to know where the water's going in your system, irrigation auditors will come out and put cups out on your greens or your fairways, turn the water on, and then measure the different amount of water in each cup. That's called a distribution uniformity analysis. This does that for you with every set of data. You can literally do an irrigation audit on a fairway in about 10 minutes. And sure enough, one of the supers there said he has a lot of problems on this hole. So we went out, we measured the hole, and we could see the front of the approach was very wet. The fairway was very dry and mosaic in its pattern. So we did a distribution uniformity. We looked at the data. It was 65%. Anything below 80 is poor. So then you go out and measure the greens, and then we put the pattern for the greens in the system and shows you what the pattern is. And sure enough, you can see why he has problems. This is a way to justify what's going on and make better decisions. Finally, we're integrating weather. Why is that important? Well, weather has an impact on your turf performance. This is the weather dashboard for the Pogo system in real time. This red line indicates a stress for a June and July disease, by the way, in the mid-Atlantic region of the U.S. It triggered an alert that dollar spot's going to show up. And guess what showed up on the east coast of the U.S. the third week of December? Dollar spot. We never see dollar spot that time of year. But it got up into the 70s, and the moisture and temperature was just right for that development, and sure enough, the system predicted it. We're doing growing degree days on the spot now with a tool. There's a lot of research behind this. The first research was just published with the system out of Oregon State University. This is in GCM magazine, and it talked about that distribution uniformity. So with that said, I thank everybody, and I'll quote my very good friend Stan Zontek, who used to say, just go out and hit it, and everything else will kind of fall into place. But I think he'd enjoy this technology if he was here today. Any questions? Yes?